Bismillahirrahmanirrahim. Let's start this June 20 P3 Pure Mathematics 3 and Variant 3.1. Okay? Chale, let's see what does this paper have for us. Pehla question: find the set of values of x for which this is this. Give your answer in a simplified exact form. Okay, this is a very dangerous thing. You have to give your answer in exact form. There are two ways of doing it. One for the people who are really good at logarithms, and secondly, the ones who are good at the indices. ठीक है ना? So I'll be doing it with both the methods. Look at this. If you straight away take logarithm on both the sides, this is ln of, you use the brackets here appropriately, ln of um, 2 into 3 raised to power 1 minus 2x, and then this is less than ln 5 raised to power x. Acha bacho, I'm just trying to write this on the extreme left here. Now this would become ln 2 plus ln 3 raised to power 1 minus 2x, and then that is uh, less than ln 5 raised to power x. Now this further becomes, this is going to become ln 2. Come on, yaar, bacho, you people are entering late and messing my work. ln 2 plus 1 minus 2x ln 3, that is less than x ln 5. Okay, now this is uh, ln 2 plus ln 3 minus 2x ln 3. See, I'm not using calculator at all, okay? So this is less than x ln 5, okay? Now this, you can write this as ln 6. This is ln 6, and you can shift this to the other side. This becomes 2x ln 3 here plus x ln 5. If you see that this can, if you take x as common, this is going to be 2 ln 3 plus ln 5. And this can be written as x ln 9 plus ln 5. Hai. So this becomes ln 6 is less than x ln 45. So let me write this to this side. This is x ln 45 is greater than ln 6. So x is greater than ln 6 over ln 45. That is your answer. X is greater than ln 6 over ln 45. Let me see if this is really the answer here. Uh, Here is the marking scheme. Yeah, this is ln 6 over. You can see this here. Okay, now the how this could be done. If there is someone who's really good at indices, you will see that this will take a lot lesser steps here. Now, we can write this as 2 into 3 over 3 raised to power 2x, that is less than 5 raised to power x. You can write it as 6 over 9 raised to power x is less than 5 raised to power x. Then you can write this as 6 is less than 5 raised to power x times 9 raised to power x. You see both have the same powers. You can write it as 6 is less than 45 raised to power x. And now you apply the logarithm on both the sides. This is ln, this is ln. So now you have this ln 6 is less than x ln 45. So your x is greater than, okay. So whenever this happens, just remember someone is entering, okay? This is ln 6 over ln 45. So which method would you prefer, bacho? The direct application of logarithm or using the indices rules here? Hmm?
So indices.
Anna, you see this is much neater and you could get to the required value more quickly. And please see that calculator is not being used anywhere at all. Even if you had to give your answer maybe correct to 3 significant figures, You should all these steps, and at the very last step, you should use the calculator. ठीक है? अच्छा, now I'm moving on to the second question now. Okay, it says expand this. Now, this is a straightforward question on binomial expansion. Okay, the formula is given to you. The formula is if you have 1 plus x raised to power n, that is for your P3. So, this is going to be 1 plus nx plus n into n minus 1 over 2 factorial into x squared plus blah blah blah. The condition here is that you must have your first term as 1. So let's try to do that. I'll be taking 2 common from here. This is 2 into 1 minus 3 by 2x. And then let me put that power minus 2 on it. Okay. This is your 2 minus 3x to the power minus 2. Achha, now we can switch these powers onto it. So this is 2 raised to power minus 2 into 1 minus 3 over 2x to the power minus 2. And this becomes 1 over 4 into 1 minus 3 over 2 to x to the power minus 2. And again, you will see that I'll be using the calculator maybe at the very end. This is 1 over 4 using this formula here, okay? So this is 1 over 4 into 1 plus n into x plus n into n minus 1 over 2 factorial into this x square. Since you have to write this up to x square, so I'm just like going to put the dots after this. And this is going to be 1 over 4 into 1, 1, 1 uh, plus 3x, and you see this is going to be this 2 is cancelled with this 2, and you have plus 3. Yeah, this is 3 into 9 over 4x square and so on. Achha. Okay, so uh, I think I haven't made any mistake here, Hannah. Please keep a check on my working. I'm used to making silly mistakes. This is 1 over 4 plus 3 over 4x plus 27 over 16x square and so on. We have to expand this up to this because it says simplifying the coefficients. Look at this, simplifying the coefficients. Okay, so let me see what is the answer to this. Yeah, this is yeah, 3x 3 by 4x plus 27 over 16. Okay, ठीक है, so this is correct. Okay, then next it says state the set of values of x for which the expansion is valid. Acha, have you ever wondered that why do we not write the terms which have the greater powers here? Hmm? Because you see, the greater is the power, it has to be more significant, more important. But we ignore these terms which are coming up, like which have the higher powers on x, because we assume that this has to be a converging geometric series. A converging geometric series, because you see that in a converging series eventually this becomes a stagnant thing, it converges to a certain value. So for that purpose, if it is a converging series, then you see that then you see that this x yeah, okay, uh, this acts as your common ratio. You can see that this is minus 3 over 2x, and then there is a square. So you see, whenever you have a converging series, your common ratio has to be like this. Okay, so this minus 3 over 2x should be like this. So you can ignore this minus sign here. This is going to be 3 over 2x has to be less than 1. That is the condition. And if you want to, remove this inequality sign, this would be between minus 1 and 1, and this x should be between minus 2 over 3 and 2 over 3 if it has to he says, let me use his own wordings, state the set of values of x for which the expansion is valid. So this expansion is valid if you have x between minus 2 over 3 and 2 over 3. Do you have any question, Bacho? Hmm. So it means I have to move to the next question. ठीक है ना? If there is no question, I am moving on to the third question. Acha, again, you should have your formula booklet with you while attempting these past paper questions. Even if you're solving a question from your textbook, you need to have your formula booklet with you. Okay, now you would be needing the formula for tan alpha plus beta, and then tan alpha minus beta, and then the exact value of tan 60 is required to solve this question correctly. Okay, I know that tan alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, that is equal to 2 plus tan alpha minus tan beta over 1 plus tan alpha tan beta. Okay, and now I know that tan 60 is, I think that is under root 3. Yes, please confirm that tan 60 is under root 3. Okay, so this is going to be tan theta plus under root 3 over 1 minus tan theta times under root 3, that is equal to plus under root 3 minus tan theta over 1 plus under root 3. Please, for God's sake, you don't have to use your calculator and don't start finding the value of under root 3 over here. Let the things be in exact form, okay? Acha, you see that there is this tan theta is coming so many times over here, and we have to write a quadratic equation in tan theta. You have a choice here. You can right now change this tan theta with the y or a, b, c, whatever you want to do. Okay, this is up to you. If you want to continue like this is up to you. But I'm feeling a bit scared with this tan theta coming again and again. So I'm going to tell the examiner uncle that I'm going to put that tan theta right now equal to y. If there was any other ratio, like if there was a sine or a cos, then I shouldn't be introducing this y at this stage. But you see, all of them are tan, so I can change that. So this might make my equation look a bit nicer, okay? This is y plus under root 3 minus 1 minus under root 3y. Don't drag this y into the square root. This is outside the square root, okay? This is 2 plus under root 3 minus y over 1 plus under root 3y. Now, guys, this is your going to be practice for algebra over here. You see that this is 1 minus under root 3y, this is 1 plus under root 3y. So I can imagine that the LCM for all these c fractions is 1 minus under root 3y times 1 plus under root 3y. So I'm going to multiply the whole of this equation by, though this is not a mathematical way of writing it, but I'm just uh, telling the examiner that I multiplied the whole equation by 1 minus under root 3y because that is the LCM. Okay, you can mention that this is my LCM over here. Okay, when you do this, Bacho, you will be left with this will be cancelled with 1 minus under root 3y, and you will have y plus under root 3 times 1 plus under root 3y. This 2 will be multiplied with both of them. And you know that when you multiply them, you can have 1 minus 3y square. Because this product is going to be equal to 1 minus 3y square. So I'll be writing it as 1 minus 3y square. Okay. And then this under root 3 minus y into plus wala will be cancelled and minus wala will be left here. 1 minus under root 3y. Now please simplify this and tell me. So I have 4y on the left hand side, and I have 2 minus 6y squared and minus 4y. That is on the right hand side. So this becomes 6y squared plus 8y minus 2. That is equal to 0. And you can write it as 3y squared plus 4y minus 1 equal to 0, where y is, just remind the examiner uncle that where y is tan theta. Okay, now you solve this through the quadratic formula and tell me what are the two values that you get from that quadratic formula. Y equal to and y equal to. Please tell me using the quadratic formula, what do you get? So when you have y equal to minus 1, y equal to 1 over 3, so we put that y back as tan theta. So we know that tan 45 is 1. Okay, so this would be in the second quadrant here. So that is going to be 135. And what is tan inverse of 1 over 3? So that will be in the first quadrant because we have to stay within this limit. What is tan inverse of 1 over 3? Come on, yaar. 18.4 degrees. I doubt if these values are really correct. Let me check from the answers here. Oh, one answer is 12.1, the other is 122.9. What are you doing, bacho yaar? Please solve these equations again, yaar. 3y square plus 4y minus 1 equal to 0. Hmm. I think someone has given me wrong answers here. 0 point? Okay, and the other one? 5? Okay. Yeah, these were the values here. Come on, yaar. What are you doing? Bacho, you're making mistakes here with these. Hmm? So, thanks God I checked the answers. Tan theta is minus 1.55. This will give me the obtuse angle here. And here it is 0.215. I'm just going to copy the answers from the back here because you people are not telling me the answers that quickly. Now, one answer should be 122.9 and the other answer should be 12.1 degrees. That is for sure. I believe these are going to be the correct answers. You can get them through this. Okay. Now, question number 4, this looks to be a straightforward question on differentiation because he's saying there is an equation has a stationary point in this interval. So find the x coordinate. So I'll straight away go for dy by dx, and I know that my u is e raised to power 2x. So u dash is going to be 2 e raised to power 2x. And then my v is sine x plus 3 cos x. So this v dash is going to be cos x minus 3 sine x. Now let's put them into the derivative here. I mean, while differentiating this, we know that if you have y is equal to u dot v, so your dy by dx is going to be uv dash plus vu dash. Okay, so let's do that. So we have dy by dx uv dash. Okay, this is e raised to power 2x into this cos x minus 3 sine x, and then plus vu dash, that is 2 e raised to power 2x into the sine x plus 3 cos x. And let me just take this e raised to power 2x common from here. Okay, so this is going to be cos x, because I might have to differentiate this again. So I just want to simplify this as much as I can. So this is e raised to power 2x into 7 cos x minus sin x, and that is equal to 0 because we have to deal with the stationary point. So one thing I get, e raised to power 2x equal to 0, I'll get no value from here. There is no solution for this. And secondly, I put this 7 cos x minus sin x equal to 0. Now, this is a typical P1 trigonometry question where you have two terms, one in sine, other is cos. How do you solve such equations, bacho?
सर आप tan में इसको convert
Yeah,
कर
we'll
लेते हैं.
divide all of these by cos actually, okay? So dividing the whole equation by cos x, you end up with 7 minus tan x equal to 0. So your tan x equal to 7. This is the interval. Uh, Change the mode of your calculator into radians, and you know that this has to be the, I mean, first quadrant here. We have to give the answer correct to two decimal places. So what is tan inverse of 7? 1.43. Just to check the answer quickly, 1.43. Where are we? Yeah, here it is, 1.43. Okay, let's see what's there in the next step, next part. Determine whether the stationary point is a maximum or a minimum. Now, he's not asking you for the stationary value, okay? It says determine that if it is a maximum or a minimum. So don't waste your time. Just find the second derivative quickly, okay? So for that purpose, I'll be using from this onwards, okay? Because this is my uh, I need that 1.43 and this dy by dx, this, which is here. Okay. So, bacho, I have dy by dx equal to this. So, d2y by dx square would be again a chain rule. So, e raised to power 2x into minus 7 sine x minus cos x plus its derivative is going to be 2 e raised to power 2x. This is uh, vu dash into 7 cos x minus sine x. Just to save your time, if you take this as common, this is minus 7 sine x, and then you have minus 2. This is minus 9 sine x. Minus cos x, you have plus 6 cos x. Okay? So just put that quickly into your calculator. This e raised to 2x, this is 2 into 1.43 and into minus 9 sine 1.43. We don't need its value, we just have to see if it is going to be positive or negative.
Sir, how are we getting 6 cos x? Because 7 times 2 isn't it 14, or minus 1 will be 13.
Yeah, yeah, 14 minus, no, this is, yeah, this is 14 here. 14 minus 1 is 13, है ना? Yeah, I made a mistake here.
Yes.
Is plus 13 cos x plus 13 cos of this. Okay, tell me, what do you get? Is that positive or negative? This is negative, therefore the stationary point is maximum. Okay? Stationary point is a maximum. Okay, now I'm moving on to the fifth question. Okay. Yes, it's a straightforward question on long division. No thinking process required. Just divide this quickly. Okay, so you have 2x cubed minus x squared plus 6x plus 3. This is your x squared plus 3. So x squared into 2x, है ना? This is 2x cubed plus 6x. This is gone, this is gone. Minus x squared plus 3. So minus 1. This is minus x squared minus 3. This. So you have 6. Achha, whenever you divide them, so Though he was asking for the quotient over here is that is 2x minus 1. And the remainder is going to be 6. You can also write that all of this division is going to be equal to 2x minus 1 plus 6 over x squared plus 3. That is what you get when you divide them. Okay? Acha. Now let's see what is there the next part. It says using your answer to part 1, find the exact value of this. Okay, so we have this. So this means the integral of this is going to be the integral of this. Okay, so my B part starts from now onwards. Okay, so I'm just clearing this. Okay, acha. So it is like this. Acha, so this becomes integral of all of this. Okay, na? And this is limit from 1 to 3. We can integrate this 2x minus 1 very easily. But the problem is with this, okay? So some of you people don't know how to use your formula booklet efficiently. Let me bring in the formula booklet for you people and tell you that how many resources you people have here. Okay, here is going to look at this. I'm going to keep it here. Can you see this thing here in this formula booklet here? That if you have 1 over x square plus a square, that this is basically telling you about the integration. Okay, this is f of x, this is integral of this. So this is where you have to use your formula booklet efficiently, bacho. Okay, so this is your formula booklet here. It tells you that the integral of 1 over x squared plus a squared is 1 over a tan inverse of x over a. So please don't waste your time about thinking yaar, how to integrate this. Okay? So look at this now. This becomes so easy for you now. This is going to be 2x integral is x squared minus x plus 6 over. Now this has to be squared. So can I say this is under root 3 square? है ना? Because it has to be x squared plus a squared. So 6 over under root 3 and then tan inverse of x over under root 3. That is the integration. You see how easily, bacho, you can score these 5 marks. If you know that, if you knew that, ek to he was giving you the clue himself that you have to use a part A. That was a division required. We have used that. And then you have to use a formula booklet for this. Okay. If it was x square minus a square, then you could have gone for the partial fractions. Anyhow, bacho, time to put the limits in here. So this is going to be 9 minus 3 plus 6 over under root 3 tan inverse of 3 over under root 3 minus, please use the brackets when you're going to put the lower limit. This is 1 minus 1 plus 6 over under root 3 tan inverse of 1 over under root 3. Okay, so this is 6 plus 6 over under root 3. I think this is 3 over under root 3. That is pi by 6 or pi by 3? Hmm? One second, let me recall because I want to do it like this. This is, yeah, under root 3. That is pi by 3. That is pi by 3. You can use your calculators, bacho, if your calculators have that privilege of giving you the answer in exact form. And this is 6 over under root 3, and this is, I believe, it is pi by 6. Okay, so now this is going to be 6, and you have plus 6 over under root 3 common, and pi by 3 minus pi by 6 is going to be pi by 6. 6 cancel by 6. Okay, and this will be 6 plus pi over under root 3. Let me check the answer quickly. This is your 1 over 3 pi. Yeah, that is the answer here. And the answer is correct, thankfully. Okay, so this was the fifth question, Hannah. And we shall go to the sixth question in our next segment. ठीक है बच्चों? Is there any question? If there is no question, we can move on to the next segment then.